All right, thank you everyone for joining this very special session for the Gemini user community. My name is Jamika Marshall, and I am the Shadow the Scientist Programs Manager. The Shadow the Scientist initiative is brought to you by a team at the University of California at Santa Cruz. Now, as you all probably know, but in case you are a new user to the Gemini community, the International Gemini Observatory consists of twin 8.1 meter optical infrared telescopes located on two of the best observing sites on the planet. Now I'm here at the Gemini North telescope at the Hilo Base Facility with the telescope itself located on Maunakea in the Summit region and is part of an international community of observatories. Now, by incorporating amazing technologies such as laser guide star, adaptive optics, and multi-object spectroscopy, astronomers in the Gemini partnership explore the universe in unprecedented depth and detail. Now, I am very, very excited to join a cast of science hosts for this session. That includes Dr. Zachary Hartman, and Dr. Eric Steinbring, and Dr. Brian Lameau. Now, Brian just stepped out of the control room for a minute, so we're going to start with Zach, if that's okay with you.
Yeah, sure. Hi, everybody. My name is Zach. I was recently, as of 6 months ago, I was a Gemini Science Fellow, and now I've moved on to a position at NASA Ames as a NASA postdoc there. And so I'm here to talk about Gemini and how the observing. Hey, and here's Brian, and observing with Gemini. So yeah, happy to be here.
Thank you so much, Zach, and I'm very pleased to have you here with us virtually. I do miss seeing you here in the control room behind me. And Dr. Eric Steinbring, hello and welcome.
Oh, hi. It's nice to be here. So I'm Eric Steinbring. I'm the head of the Canadian Gemini office. So like Jamika said, Gemini is an international partnership, and there'll be representatives here, folks from the other partners as well. I'm also a support astronomer. So my role is to help Gemini users get their phase 2 ready, so get their program ready to go on the telescope if they're observing in the queue. And also I help with the administrative aspects of operation of the telescope through the Ops Working Group, through a committee that coordinates the calls for proposals that international partners can apply for. So that's coordinating with the TAC to review proposals, and then support, like I said, support for when those proposals are turned into observations. So I'm connected with several aspects of how Gemini operates here and through here in Canada.
We're so very pleased to have you, Eric. Thank you so much. And Dr. Brian Lameau. Welcome, Brian.
Hi, Jamika. Good morning.
Good morning.
Well, it's so nice to have everybody on. I want to especially thank Jamika for getting up at 4 o'clock in the morning with me. Our observers and operators who are taking data right now on Gemini North, right behind Jamika. So that's Layla Alamos and Jen Miller. Zach for joining from California at 6:30 in the morning, and Eric joining from Canada. I'm Brian Lameau. I'm a staff scientist here at Gemini North. So I have a variety of different jobs. I do research in my spare time. I support various aspects of the observatory. So right now I'm the Q coordinator, meaning I'm managing our pool of observations for a given night, choosing for the various weather conditions, the highest scientific output as far as our metrics go. I am sometimes in the same chair that Jen is in tonight, so observer chair. Every once in a while, I'm in the chair that Layla is in tonight. One night I've been there, the operator chair. And I also do phase 2. I am the GNIRS, one of the GNIRS instrument scientists, so I'm involved with all things GNIRS. And we, in fact, have this session tonight because we're just about a week outside of the phase 2 deadline. I'm sure a lot of people on this call are keenly aware of that. And so we will go over, among other things, how you might approach phase 2. Maybe some of you have me as a contact scientist, so get to know me a little bit better, and then how you might proceed in terms of approaching our observing tool, which is not the most transparent tool in the world, and then how you might get your observations up and ready. We'll also look in at night operations. So this is live. We are in Hilo, Hawaii right now. It is 4:38 in the morning. Jen and Layla are using the telescope right now. And so we'll go over a little bit about what the operations model is, what they're doing right now, how the instrument works, so on and so forth. So let me get started with a quick overview of the session and a few very basic things about Gemini Observatory. Eric, you said you had to leave after 30 minutes or so? Or take a break
Right.
anyways?
I don't know that I'm needed in detail, but for much. But yeah, I leave at about 7, and I can come back online at about 7:30 for the remainder.
Okay. So maybe I'll do like 10 minutes and then I'll pass it over to you, and then you can give like a quick overview of Canadian NGO and kind of your guys' role. And then we can come back here and then finish up some basic stuff about Gemini and then go over to night operations, if that sounds okay for you.
Sounds good.
Okay, so I just want to say to everybody that you're welcome at any point. This is the first time, first of all, that we've done a session like this. We've done a lot of sessions for graduate students that have interacted with the observatory, in particular for the graduate student visitor program, which was an awesome program that Zach ran last year or earlier this year. No, last year. We've done it for various PIs of a Gemini one-on-one. We've done it for classrooms, but we've never had a group of PIs or program teams that have come on. So y'all have observing experience. Maybe this is your first time interacting with Gemini Observatory, but please feel free to interrupt at any point. Raise your hand, write in the chat, whatever you want. And this is completely organic. We're just going to kind of follow things as they go. Yeah, so feel free. It's completely informal. Just to say, this Shout of the Scientists is, I'll talk a little bit more about it later, and I know Jamika did some in the intro. This is an awesome initiative that's run out of UC Santa Cruz, spearheaded by Raja Guhathakurta. Jamika is our awesome Shadow of the Scientist programs coordinator. So it's not just Shadow of the Scientist that she does. And Shadow of the Scientist is supported by UC Santa Cruz, Heising Simons Foundation, and a huge slew of volunteer outreach organizations and professional scientists. So as I said, no serious plan. You're welcome to interrupt at any point. Raise your hand. Honestly, I'm happy to go through like example phase twos if anybody has their phase two like started, absolutely no problem to do that. So I'll just do a quick overview of the observatory, Zach and I will, and the Gemini operation model and the phase two process. We'll check in with the night crew in a little while, see what's going on with night operations. Eric will discuss the role of the NGO representatives and the Canadian NGO in particular. And then I have a few specific examples of phase two, Zach does as well, in the OT that we can share. This session is recorded. You probably all saw when you came on. We're going to share it on YouTube. So this is for I've gotten lots of emails from PIs that asked for this to be shared as soon as possible so that they can scramble for their phase two when they get some time. So y'all are probably familiar already, but just a quick overview of the observatory. We have sister telescopes, one in Maunakea, here on the big island of Hawaii, in the middle of the Pacific. And then our sister telescope is at Cerro Pachon in Chile. Collectively, we see the entire sky. This is great for a variety of different reasons, especially targets of opportunity. Each telescope is not an identical twin of the other one. So we have different instrument suites on the two telescopes, different capabilities. I'll be highlighting some capabilities of both telescopes in a little bit, though I'm sure most of you are already familiar. Partners are the United States, Canada, Chile, Brazil, Argentina, Korea, and the University of Hawaii. So let's see, maybe I'll go over a quick overview of the capabilities. If you guys don't know the capabilities outside of the instruments that you've proposed for, Eric kindly pointed me to our shiny new Gemini capabilities handbook. This is it here. There's a URL that you can get. You can download it. There's a QR code there. But basic premise is we have optical and near-infrared imaging capabilities, spectroscopy, and adaptive optics on both telescopes. GMOS, which probably a lot of you are interacting with or have interacted with in the past. This is a capability that we have on both telescopes, a 5x5 augmented field of view with a slew of filters, long slit imaging, long slit capabilities, IFU capabilities, MOS capabilities, which is what I love. And then we have speckle imagers on both telescopes, which Zach knows very well. We also have near infrared IFU and multi-object capabilities, and then AO on both telescopes. So Zach, maybe I can pass to you to do the Gemini North slew of instruments. I can do the South.
Sounds good. So as Brian has mentioned, and a lot of you probably know, Gemini North has this large suite of instruments. GMOS is our workhorse instrument, which has an imager, long slit space capabilities, integral field, and multi-object spectrographs. I think it takes up like 40 to 50, 60% of the amount of Gemini North time. So it's very widely used in the community. ALTAIR is our speckle and rapid wide field imager. It's my area of research for speckle imaging, and I'm out, and actually the postdoc that I'm at now is working with the NASA speckle team, which runs ALTAIR and Zorro at both Gemini North and South respectively. MAROON-X is a high-resolution spectrograph, which is really optimized for radial velocities of low-mass stars, in particular M dwarfs. And these are the optical instruments. And then in near infrared, we have two. GNIRS is a longtime resident at Gemini with long slit and cross dispersed spectroscopy for the most part over its long career, and just recently has been integral field units have been added as capability. And it has a small field of view imager, which is still really good, and GNIRS can be used with the AO system. IGRINS 2 is a new facility instrument that we added over the last year that is basically a newly built, wouldn't say copy, but based on the IGRINS from Gemini South. that's now, I believe, at McDonald in Texas. And so it's a high resolution near infrared spectrograph that allows you to get the wavelength coverage from 1.5 to 2.5 microns. And I know tomorrow night they're starting an engineering run, and then it's going to join in on as a Q, pseudo regular Q instrument at that point as well. And then ALTAIR is our adaptive optic system, which provides for natural guide star, but also laser and superseeing mode. And for the moment, the only instrument that can use it is GNIRS, although I know there's been some discussions about moving it to other instruments. And yeah, so that's the North. So
Zach, can I impose on your generosity? My Q coordinator duties have called, so I have to run into the control room right now.
All right, I will.
And then maybe Eric, after this, you could talk a little bit about NGO stuff. I just don't know how long it's going to be, but you'll see me on the other camera here.
Do you want me to share the screen so I have control of the slides, or?
Sure, yeah, that'd be great. Yeah,
let me grab this one then. Oh, that's not what I wanted. Okay. All right. Share slideshow. All right, can everybody see this? All right, I see thumbs up. All right, let's go to where we were. So Gemini South also has GMOS. So GMOS and the two speckle instruments are basically copies of each other on the two telescopes. So we have both of our workhorse instruments at Gemini North and South with GMOS, both being there. GHOST is a new instrument that just came online in the last couple of years. It's a high resolution of cell spectrograph, which is capable of getting single targets and two possible targets using two fiber bundle IFUs. Zorro is a copy of Maunakea in the north, speckle and wide field imager. Near infrared, Flamingos 2 is a long-running instrument down there as a near infrared imager and multi-object spectrograph. GSAOI is the adaptive optics instrument at Gemini South, providing wide field adaptive optic imaging, and it is used with GEMS. And as it says there, it's in development with Flamingos 2, and I don't know the status on that anymore. So with that, Eric, do you want to talk about the role of the Canadian Gemini office?
Sure, thanks. So in the partnership, Canada has an 18% share of Gemini, and we're partners from the beginning of Gemini and have been involved in building instruments. So for example, you just mentioned GMOS, those were partly built in Canada, as well as ALTAIR and GHOST were built in part in Canada. And so there's the development of the instrumentation and the observatory is shared amongst the partners, and that's Canada's contribution. And so we also have expertise within Canada that helps with observing with those and the other instruments. So there are four people in the Canadian Gemini office. It's myself, Tim Davidge, Stephanie Cote, and Wes Fraser. And we also, being involved in instrumentation, are also contact people for the instruments as well. So for the phase 2. So when you get your time, as several people here on this call will just receive their letter, us and the other NGOs will have folks that will be the primary contact for you to do your phase 2, and then that will get your program on the telescope. But we also helped before that. So in Canada, we also did the technical assessments of the proposals as they come in. So as the proposals, as you know, when you sent your proposal in, it went to the TAC of the particular partner. And so we interface with the CanTAC, the Canadian TAC, but the other partners will be similar in that we provide the technical assessment for the proposal, and then we're also available to answer questions and help you in writing your proposal. So just remember that your primary contact is that you can contact your NGO, contact your phase 2 support person, for example, because they're your first line of contact for preparing proposals and getting information. You'll also notice that that they will be the primary contact for help desk tickets. So when you send in a question to the help desk, that's probably somebody at your own NGO that is going to be the primary person. And if they can't answer the question, they'll escalate it through Gemini to somebody who is an expert in that thing, and get the question answered. And it extends beyond, and for the CGO, that expertise is available and extends beyond that. So for example, when you have your data and are processing that, not only was the help desk ticket a way of getting information, but we're also involved in phase 3, if you will, in that you can ask questions about data reductions and that as well. Again, so your primary contact for your phase 2 is probably a good person to ask. And we also, of course, are connected to the other aspects of observatory governance for broader things. As you become familiar with the observatory and want to get more involved, we also can get you in touch with members of the staff. So that's the Science and Technology Advisory Committee. Those people for Canada, there's 2 of those members of that committee that you can talk to, you can connect with. They're certainly interested in hearing about from you, as well as a user committee. So the user committee will also have contacts within each partner, and they of course are directly interested in your experiences with the observatory and want to help. And beyond that, of course, the NGOs will also be connected to and can talk to the board members, right? So each partner will have members on the board in the governance of the observatory. So all of those things are all available to you and through your NGO. That's our job. Our job is to help you make the most of the observatory. And I'll conclude then by saying for Canada, you could just Google the Canadian Gemini office, and you'll get the contact information, my email, for example, and please reach out. Beyond that, as you may, for Canadians anyway, you will probably get emails from us through CASCA, through the Canadian Astronomy group, which will be possibly similar for the other NGOs as well. It's that information via your professional committees, or for the US NGO, I know there's information available through through Twitter, or X as it's now called, and on the other social media. So those are ways of connecting to your NGO. Thanks.
Thanks, Eric. Yeah, so as you can see, Brian is hard at work QCing in the control room still. So I'm just gonna move on in the presentation, and let's see here. Can I share the screen again? I can't. Aha, there we go. All right. So we just wanted to go through a couple more of the different observing modes that are available through Gemini. The main one is Q observing. which is what we're seeing right now in the control room, where Gemini staff carry it out. There's a QC, which is Brian this time around, and they go through and they run the programs through the night that are prioritized by the national tax, who give Gemini rankings, which are then put into a schedule. There are also two other modes. There's priority visitor mode, where you can come and observe at Gemini. Your program would get priority, but you are also expected to observe other people's programs in case, the weather is not as good as what your program requires, or, there's some of your targets just aren't up, and we've had that case before. As Brian mentioned earlier, there was a graduate student visitor program, and that's currently on hiatus, but we'll see whether or not it returns in the coming years. And then finally, there's classical mode, where you come to the observatory, you get the night, you run the telescope, and that's like other telescopes as well. And I will note that for the classical and priority visitors, priority visitor mode, those are funded by the program team. So if you want to come out to Gemini, it is unfortunately on your dime. But I will say that, even if you don't have a program, or your program is band 3, and as it notes on the slides, priority visitor mode and classical mode, I believe, are pretty much only band 1. But even if you have a band 2 or band 3 program and you happen to be in La Serena, or you happen to be in Hilo at any time, you are more than welcome to bug Brian and come visit Gemini North, or bug anybody at Gemini South and get them to let you in, and see the facilities there. So yeah. So I'm gonna turn this over to Brian as he's doing the QCing, and let him talk about the Q system, as he's the expert right now on the Q. So take it away.
Okay. Zach, do you mind if I take
Yeah, I
back
can
sharing?
give it back to you.
I realize it's pretty schizophrenic, but this is kind of nighttime operations at work, so this is how it's done, guys.
We have a request for the slide to this presentation. Can that be made available after?
Totally, yeah. I'll send that out to everybody. Yeah, the conclusion of the session, and then I could have a link to it on the recording that we put on YouTube as well, Jamika.
Perfect. Sounds great. Thank you. And thank you for the question, Renee.
Yeah, so this is the Q system. I just a caveat, I grew up on a classical system, so I was observing with with Eric actually at Lick Observatory. So we would go out, we would trudge out to the Mount Hamilton and take the 10-inch, I think, Eric, and just sit there and observe all night, no matter what the conditions. Keck Observatory and Subaru Observatory mostly was what I did my PhD with. And so that was, you go to the telescope if you're lucky, otherwise you do it remotely, and you get the conditions that you get. And in my case, I'm usually looking for high redshift galaxies, and so a little bit of clouds. Well, we're not so happy. But the Q system is very, very different. It's a matrix, and we on any given night we have one staff member that's designated as the Q coordinator. We typically have like week-long shifts, if we're lucky. And our job is to, during the day, coordinate all of the daytime work. If an instrument goes down during the day, to coordinate that work and to try to understand what that means for the Q, and to make plans for every possible set of conditions, and every possible set of instrumentation suite that we have available on a given night. So luckily our instruments are very stable. Usually we don't have catastrophic failures. And so we just make about 10 different plans on a given night. This is both in the north and in the south, for different weather conditions. So these, you probably already know, is some combination of water vapor, surface brightness, image quality, and cloud cover. And so you can see in the example here, this is our queue planning tool, which all queue coordinators know and love. And you can see that there's these different plans with and without laser guide star observations, because sometimes we have laser guide star, sometimes we don't. Then photometric conditions, which is also called CC50, and then a variety of different variants besides that. So thin cirrus, which is CC70, and then terrible seeing, for example. We've changed some of this nomenclature, but IQNE is what we call it. So any combination of conditions, the observer, who's Jen tonight, she would look out for the conditions all night. We have nonstop measurements of water vapor, of image quality. We know the surface brightness at any given time, and we know the cloud cover at any given time. And so our job is not only to complete as many Band 1 programs as possible, and in general, as many programs as possible over the course of the semester, but we are obligated not to give you data in worse conditions than what you requested. So one of the things that's really, really important for you all as program teams, PIs, is take a look at the ITC. So you now have an accepted program. Now it's trying to get that program observed. So make it as easy as possible for us to schedule your observations. And what that means potentially is flexing the conditions that you asked for. So you asked for something in phase 1. Let's say you asked for IQ70, CC50, water vapor 80. Well, supposing you are observing, I don't know, I-band imaging of a non-sidereal target. Water vapor doesn't mean anything. So then you can flex to water vapor any, and that allows us to observe your target on 20% more nights. Or supposing you look at the ITC and you say, if I plug in my target's magnitude, the spectral profile, the spatial profile, so on and so forth, actually I'm getting, probably a little bit more signal to noise than I need under the nominal conditions under IQ70, CC50. And so you can put a note in the program saying, let me flex to IQ85, CC50, or IQ70, CC70. And that opens up a huge slew of nights that would otherwise not be available, that we're bound by contract with you all to not take your program under those conditions. And so I do this when I have a program. So I have a program at Gemini South, which I'll show later. And I have all sorts of notes. The program is just littered with notes like, if it's surface brightness 80, I can accept IQ70 CC50. If it's surface brightness 50, I can accept IQ85 CC50 or IQ70 CC70. And so having this flexibility is really, really important for the queue system. So prepare your program early. If you have targets that are up right now for 25A, we can observe them at the end of the night during the 24B semester. So that's really, really important. Check in with your contact scientists early and frequently. So, not that I'm begging for more emails, but just, we are here to help, and there's a lot of things we can do. Rely on our expertise to get the most out of your observations. And if you're having issues or you have uncertainty about the ITC results or something associated with the OT, just write to us and we're happy to help. And then, as I already mentioned, flexing the program constraints with the caveat of don't compromise your science. So, make sure that you get what you need out of the observations. So don't go to IQNE, CCNE, when you propose for IQ70, CC50, if you're not going to get the requisite signal noise. So very, very roughly, varies a lot based on the semester and the site. But band 1, band 2, band 3 completion rates are 70%, 50%, and 30%. So you can see the need for flexing, especially if you're in band 2 or band 3. And then if you want to learn how to be your very own queue coordinator, we do have a card game. And this is something we pass out at AAS meetings, for example. So if you're going to the winter meeting, just next week, stop by the booth. I'll make sure that they have at least a few card games that y'all can pick up, but come early because they run out very, very quickly. So it's reasonably fun. I've played it a couple times. Even as a QC, in my spare time with friends, I've played it. I've actually taught some of my family members how to play it. And it's pretty close to reality. It follows our real rules. Like the wonderful elation of completing a band 1 program and the frustration of bad weather. You're trying to check out one of the instruments, and it takes you 3 or 4 rounds just to even check out the instrument. That's very normal for us, where rounds are weeks, for example. And our observer tonight is actually one of the cards, so you can play as our observer tonight. So y'all know already the regular way of getting time on Gemini North and Gemini South. There are a variety of different ways. In case you didn't know, there are large and long programs. So this is a call that's out right now, in fact. And this is multi-semester programs. If you have a very grandiose science idea that requires one or both telescopes, this is a pathway available. And I think this LLP cycle, there's no band 1 time available for Gemini South, but you can propose for band 2, and there's quite a bit of time, I think 80 hours or something per semester. There's band 1 and 2 time available for Gemini North. We have fast turnaround every single month. This is a wonderful, wonderful, wonderful program that I support among several other staff here. This is a program where you could propose, and theoretically within 3 weeks, if your contact scientist is very fast, within 3 weeks you get data. So it's like fast. And we usually prioritize these in the queue, so they're a little bit higher priority than a regular queue. So as long as you have reasonably flexible conditions, you'll get the data within a month of proposing if you're successful. There's DD time, and there's poor weather, otherwise known as band 4, which you can send in a proposal to our head of science operations and get time. And this is reasonably successful. I think we get like 50% of the band 4 data are taken on a given semester, something like that.
Brian, can I jump in here with a quick
Yeah,
question?
of course. Yeah.
Right. It's I sent it to you also and to Zach. It's from Jonathan Carney. What are the completion rates for a short time window, like 1 weekish TOOs by band?
Yeah, so I don't have the exact numbers, but TOOs in general, even band 3s, which are not allowed to be TOOs but are like TOO-ish, they have a much higher success rate than the regular Q programs in a fixed band. So this has to do with how we manage the queue. One of the first things that we do on a given day is we look for any time constrained observations. So MAROON-X, which has a lot of time constrained observations where we're looking at different, phase angles of planets going around parent stars, or we have transits, for example, planetary transits. We tend to prioritize those observations, and the same goes with STOOs. So over a 1 week time scale, I hate to say this, but probably it doesn't matter so much the timing window, as long as you give yourself enough temporal baseline to, if you have specific condition constraints. So if you're really asking for IQ 70, CC 50, chances that you get that on any given night are 35%. And so, you'd want at least 3 nights to sample well the weather conditions, assuming each night is not correlated, which it is. And so, but if you have like no real strong constraints on the conditions, the window doesn't matter so much. So 3 days versus a week, we'll probably get it done. And so, yeah, so the success rate is quite high in general. And band 3 TOO like observations also, I would guess, I'm supporting one program this semester. we have completely finished it, and it was 21 hours or something like that. So it's, yeah, a lot of success.
Thank you, Brian.
Yep. Okay, so getting help, of course, contact scientists, but contact scientists always appreciate when you check the website. We have a ton of helpful information on there, especially for phase 2. We can go through some of that later. But the observation preparation section of each instrument is your friend. It has tons of useful information. For GNIRS, for example, it has all the configurable elements, tables that show you what you might choose for integration times and coads for each type of source, different brightness. We have a telluric search tool that you can get telluric stars that are appropriate for your target, so on and so forth. So there's a lot of information on the website. Sometimes it can be hard to find. But just reading through the observation preparation section before starting phase 2 is a very good idea. Of course, primary and secondary contact scientists. After your program is done, and sometimes even during the semester, it can be helpful to interact with our help desk system. This is NGOs and sometimes like instrument scientists that respond to tickets on this. So you're welcome to ask any question there regarding proposals, time allocation, program preparation, data reduction. So we have a whole department, science user support department, that helps with data reduction. They're all on this ticketing system or anything else related to Gemini. And we will have a booth at the winter AAS meeting. And then we have a special session on Gemini Observatory from 9:30 to 11:30 a.m. at the AAS on Thursday. So phase 2, we're at that time of year. So 25A is just 8 days from now. So don't panic. This just means starting your phase 2. So of course it's better if you get it done early. It's going to take us longer if everybody waits till the deadline. I'm supporting probably 20 programs this upcoming semester. So if everybody sends me their phase 2 on January 16th, it's going to take a while. I already have some PIs that have sent me phase 2, and we're almost to the point of being done. So I highly encourage that. It's really helpful for us as contact scientists. We can give more attention to your program, and we can get things ready so that it's ready to go. The second your program is observable, it's already in the queue, and we can already put it in our matrix of queue planning. But if you don't have time, starting the phase 2 process by the 16th, even just emailing your contact scientists or the NGO that's the first line of help for your program by the 16th is the way to go. There are observing tool tutorial videos on our Gemini website. These are done by Andre Nicolas Chenet, who was a staff scientist here a while ago, who's now part of the Noir Lab leadership. And they're very, very helpful. In fact, when I started as a staff and I was very daunted by the observing tool, I watched these videos and it was very, very helpful for me. There's general phase 2 checklists, and there's one specific for each instrument. So running through those checklists before you send the observations for review for the NGO or for the primary contact scientist, very helpful. And then here I have a QR code and a URL for some high-level phase 2 reminders and commonly overlooked aspects of phase 2 that are all written by the instrument scientists of the respective instruments. So this is something we actually did for ourselves and for the NGOs to help with phase 2 support, but it's totally fine for y'all to look at them. It can be a little bit technical and a little bit daunting for somebody that hasn't really looked at the OT before or considered in deep detail about Gemini observations, but it may be helpful to take a look. Just to get an idea of some things that you might miss.
Brian, we have another question that I will post for everyone in the chat. When the TOO program is triggered, does the Gemini staff check whether that type of target is what the program initially proposed?
Yeah, so we definitely do. We give broad berth, so basically, it's within the realm of the proposal. We're not overly specific about what the target could be. If it looks like the target is outside of the broad range of what is proposed for, then we will interact with the PI and try to get clarification. And if it seems like it's outside of the range of what was proposed for, then we will deny the trigger. We also have a whole triggering policy that has to do with sharing data. Jen Andrews is the one who runs that here at Gemini North. And so if you're a TOO PI or program support, you'll almost certainly work with Jen at some point. And this is primarily in place to deal with conflicts. And so if TOO is that exciting that you're going to start triggering outside of the science that you propose for, chances are somebody else is triggering as well. And so we try to be open about sharing data if at all possible. We work with the program teams to share data. This is a community-based observatory. Anybody in the world can apply. And so this is our goal. So we will try to make it work one way or another. But it's very rare that I see triggers denied, but maybe we ask people to expand windows or to share data, so on and so forth.
Perfect, thank you.
And then eavesdropping. So eavesdropping is available for all Band 1 and Band 2 programs, including FT. We can make exceptions for Band 3 if you're really, really interested and you have a Band 3 program. Actually, the PI of the program that we're observing right now, at least when I left the observing room, was eavesdropping, watching her data come in, and we'll talk a little bit about that later. This is just an example of a note that I put in the program that I'm leading on Gemini South this semester. And it's very simple, eavesdropping in all caps. All caps can be helpful to a point. And then my name, my phone number, when to call, and then you put in, we have a spreadsheet that is linked in your acceptance email, and you'll just put your contact designation in that spreadsheet for any night that you're interested in being called. And then we will source that and then look at your program note, say, okay, this is this person, and we'll give you a call from the control room. This is done on a discretionary basis, a best effort basis. So if the observer has too much going on, they're not required to call. But most of the time, the observer is very happy to call, and at least for some aspect of the observation. So it may not be right at the time that you wanted it, because night operations can be messy, but it'll be sometime likely during your observation. It's exciting. It's exciting for you. I'm eavesdropping in Chile as my data are coming in. It's exciting for us as a staff to interact with PIs and people that are interested in the observations being taken. So please sign up for that, and let us know that you're interested. And as a reminder, your data is effectively instantly available for you to download on our archive. So you can download it 20 seconds after we take the data, and you can start reducing it and taking a look at it. And then the last slide that we have here is Shadow the Scientist. So this is what we're doing right now. And this is what I've been involved with for like 4 years now, something like that. And Jamaica's been involved for a similar amount of time. Zach has also been an amazing partner with me at Gemini North, and now even when he's moved on to other things. So just a quick bit about it. It's as I mentioned earlier, Isaac Simons funded program at UC Santa Cruz under the Creating Equity in STEAM umbrella of programs. The idea of the program is to open up the doors virtually to the various observatories around the world, and more generally to scientific laboratories. So it's not just limited to astrophysics. Some of the host telescopes that we use, my research group uses, and we use as a staff, are shown here on the left and middle portions of this slide. So Subaru on Maunakea, the two Keck telescopes, the Gemini North. We're doing our first Gemini South session coming up in a couple days, and Lake Observatory, among many others. We have outreach partners all around the world, but we also rely on partnership with scientists. So it's again, it's community-based and really organic. And so y'all are professional scientists. Come host a session with us. I've done 50 sessions, probably, like half of those with my research group. It's super exciting. It's not a lot of activation energy. And honestly, when you're observing at 4:30 in the morning, there's downtime. And having people interested in what you're doing and being able to share some of the wonders of the universe with people that would otherwise never get that opportunity is a really amazing experience. So I'm going to stop there. Maybe we can pause for any questions. Zach, did you have anything to add to anything that I said?
Nope.
All right, we do have a question, and thank you for that fabulous explanation about the Shadow the Scientist initiative, Brian. It's been a pleasure to work with you and Zach on Shadow the Scientist. And of course, we had our first session in October of 2022, me, Zach, and Brian, and I just got everything going. So it's a pleasure to have the honor to work with you all again together.
Impressed.
Okay, so question here. What properties are checked during the quality assessment stage before the data is uploaded to the archive?
Yeah, so that's our observer that does the check on a given night. So we have like multiple levels of checking. The observer is the first line of defense there. So we look to make sure that if you're taking spectroscopy, targets in the slit, that getting roughly the signal to noise that's expected based on the target brightness and the ITC. And then making sure that there's no defects in the data. So for example, in imaging, a satellite trail running through, we'll retake those steps. If something happens with the instrument, we lose guiding for a short period of time, pausing the observation if that's possible, for example, for GMOS. Jen is actually really amazing we have seeing bubbles all the time, and so she pauses observations during these seeing bubbles to make sure that the data come back with the as best as possible to ensure that the data come back with the quality that is expected for the condition constraints. So once all that's done, the observer will say, yeah, it looks good. So I'm going to pass it. Now, supposing the surface brightness, when it was a little bit higher than what was requested. So we have specific timing windows for a given observation, but supposing it went, 5 minutes over and it's 5 in the morning and the observer doesn't notice, and okay. During the day, we have a science operations specialist that runs scripts that double check that, based on cloud cam coverage, based on known surface brightness profiles throughout the night, based on measurements from our wavefront sensors and from other telescopes on image quality. Was everything in spec? Was there any possibility that something was out of spec? At the same time, the Q coordinator is looking over the data and checking, does it look like the observer potentially went past a window, or did they accidentally take an observation that was supposed to be IQ 70 and IQ 85 conditions? And so those 3 levels of checking is what happens. Some of that is automated, some of that is a little bit subjective. But in the end, it's very rare that data get passed and the PI isn't notified if it's on the borderline. So if it's at all on the borderline, like one of the jobs of the Q coordinator is to say, hey, listen, last night, the last step of your sequence was taken in surface brightness was a little bit brighter than you requested. However, it was also IQ 70 while you requested IQ 85. It was also CC 50 while you requested CC 70. I just sent an email out like this today. And so it actually seems like your signal to noise would be much higher than what you would expect. Just let us know if something's wrong, check the data. And then if you say, no, it looks like the signal noise is not good enough, which happens sometimes, then we retake the step. So no questions asked.
Brilliant. Question from Tomas. What should be the twilight limits for the science observations?
Whatever your target can handle, honestly. I mean, you're not really choosing this. So like, okay, if you have a timing window, yeah, maybe, but timing windows probably shouldn't be that strict. But if you're choosing surface brightness any, we're choosing when to schedule that observation. And it usually comes down to when we can guide. So we, like MAROON-X, for example, has fairly bright targets, or we take bright tellurics at the beginning of the night in the near infrared. And so that really comes down to when our optical guider can pick up a guide star. And so if you have a bright guide star for peripheral wavefront sensor, on instrument wavefront sensor, we can start science at like 6 degree. Honestly, I don't like when does Alopeke and Zorro start? Around 6 degree? Is that?
I think we typically wait for 12.
Well,
I mean, it's the wavelength dependence, right? I mean, if you're in the IR, you're going to be able to push it a little bit more than the optical.
right. Yeah, but you still have to have the guide star, which is going to be an optical. So
Right.
yeah. But usually I schedule MAROON-X observations before 12 degree. And probably you did that too, Zach, when you were a Q coordinator.
I think it really depends. I mean, you know, for me when I was Q coordinating, for the most part, you can schedule stuff before 12 degree, but it was also like you wanted it to you could slew to it. Science, there's some science where it's just like you have to wait till 12 degree, and sometimes you have to wait. So
Yeah.
it really just depends on the science of what you can take.
And I should say, like, the Q coordinator proposes whatever they propose, but it's the observer that's really deciding. And so whenever, usually I'll say at the beginning of the night, like, whenever you can. So you can take it early if possible. And then at the end of the night, then just hold it for as long as you can. But we try to use every spare second of telescope time. And that, that includes at the end of the night, much to the chagrin of observers sometimes, at the end of the night, scheduling twilight flats, either imaging twilight flats or spectral twilight flats, which for the GMOS IFU, for example, can go past sunrise, which is fun on a 14-hour winter night.
Okay, we have a related question from Renee Mendez. Is it possible to propose observations on twilight near the sun for comets or asteroids in the inner solar system?
Yeah, absolutely. So as long as we can, I mean, for imaging observations, as long as you can handle it, like in terms of surface brightness, and the observation can handle it in terms of the surface brightness, the science can handle it in terms of surface brightness, and we can guide, no problem. Yeah, no real restrictions.
Yeah, I seem to remember when NIRI was still running, which was a near infrared imager, wide field imager, and also IO imager. I mean, I think the first semester I was there, I think we had a Venus program or something like that was like really like pushing twilight. So, I mean, yeah.
Yeah, if we can get science out of like 6 degree to 12 degree, that's bonus, because we actually calculate our science time as being 12 degree to 12 degree. So, it honestly in the evening twilight, I mean, we tune and we usually get a photometric standard and stuff if it's a photometric night. But we have a little bit of extra time in evening twilight. It's usually for the best because we're just trying to get set up for the night and assess conditions and everything. But we're not struggling. Like, you know, we have a little bit of extra time. So if you have something, a program that you can think of that utilizes that time, the observatory would very much welcome it.
Yeah, and I will say that, you know, as Brian just mentioned, you know, the observatory counts science time as between 12 degree and 12 degree. So if you have a program that is technically all between 6 and 12 degree, you could, I mean, that's technically, you will never get charged science time to that program because the observatory doesn't count as that. So
Perfect. Another question, which I will post in the chat now. Is there something that is the hardest to observe?
GNIRS.
Yeah, I would guess like, well, staff in the north would probably have different answers than staff in the south. I don't know. Jen, Layla, what do you guys think? Hardest observation that you guys take? If you're free to talk.
Yeah, we're just getting set up on a program, but I'll think about that and come back to you. I think all different instruments have different quirks to them, and I wouldn't say one's worse than the other.
It's GNIRS. Come on, it's GNIRS.
Well, when we have GNIRS crashes, that's a little tough to deal with.
Yeah. So we've had a lot of like really creative proposals for GNIRS recently, and Zach mentioned the IFUs. So the IFUs, we have 2 IFUs on GNIRS that we've commissioned over the last couple of years. I was a part of that. One that's a low resolution IFU, which is 3 by 5 arc seconds, and the resolution can go up to about 7,000 or so. And then a high resolution IFU, which can be AO fed. Actually, they both can be AO fed, but NGS fed. Actually, they both can be NGS fed. So sorry, a Nyquist sample, the high resolution IFU Nyquist samples are NGS point spread function. So that's 1.1 by 1.8 arc seconds. Those are pretty tough observations in general. Just setting up the observations can be tough. But we've had some really creative proposals recently through fast turnaround and through DD that have used NGS with GNIRS modes that don't typically use NGS. So low resolution IFU. So one program is trying to do basically Nyquist sample the PSF by taking small step, like half pixel steps. So basically drizzling, if y'all are familiar with drizzling from HSC or JWST. So trying to sample the NGS PSF by moving the LRIFU in half pixel steps, and seeing if the stability of the PSF over time is good enough to be able to Nyquist sample. We also had a recent observation where it was cross-dispersed GNIRS with NGS. So it was off-axis NGS and cross-dispersed. So it was a bright target and then a faint companion. And the faint companion, we were putting the cross-dispersed slit on that. And we had the diffraction spikes from the bright star that were rotating around as the spiders holding the secondary were moving from the gas rotator. And so we had to get we had like 20-minute windows because the declination of this target was basically exactly the latitude of Maunakea. And so it was transiting. And so it was, for the vast majority of the night, it was sitting where the diffraction spike, one of the diffraction spikes was right on the secondary companion. And so we had to get it right at transit when this diffraction spike, the gas rotator was going crazy and the diffraction spike was moving and flipping around like this. And so we literally had 3 windows in the night. We had taken this observation 3 times. We had to do a ton of calculations to make sure that, okay, these windows are okay. And it was, I think we had 35-minute windows for a 22-minute observation. That didn't include the actual setup. So luckily we had awesome observers. We always have awesome observers, and they were right on it and we were able to get it. But that was like insanely challenging.
Perfect. That is, oh, I was going to say that's all the questions we have so far, but we have another one which I will also post. Is from Renee. What are the main ingredients in the completion rates of the different bands? Is it all related to sky conditions, or are there other factors?
Yeah, so I would say completion rate increases with the number of emails sent to the contact scientist. Again, I'm not inviting more emails, but really working with the expertise at the observatory is incredibly important. So knowing which notes to put, flexing, maybe you don't want to flex, you don't want to compromise on condition constraints at the very beginning of the semester, but as let's say you're band 2 or band 3 PI, and the semester's halfway done or 2/3 of the way done, and you're not getting any data, checking in with the contact scientist saying, hey, might I consider flexing, putting more integration time on a target, and then making the condition constraints a little bit looser so that I can at least get one observation through. These are all really helpful things to do. Just, yeah, more flexibility in the program, honestly. If you can distribute your targets in RA, if possible. Flexing conditions. I don't know. Can you think of anything else, Zach, that might help target schedulability?
No, I think you've covered it. I mean, I think the best band, like if we're just thinking about, completion percentages in band 3, for example, the best ones that are the ones that get the most out of band 3 are the ones that either, they can take any condition whenever, or they have 500 targets and can take
So your program, Zach.
Yeah, so my program, and can take not the best, but not the worst conditions either. So, it's really, I mean, if you're asking for, dark time as a band 3 program, your chances of getting observed are pretty low. But if you can flex that into gray time, then your chances go up. So I would say definitely sky conditions, but also, where, as Brian was saying, a large stretch of targets spread across the sky.
Yeah, and don't rely on your intuition. Like I'm constantly challenged on my intuition in terms of the target, like an observation in Z band, like how affected by the surface brightness is that? And going into the ITC and actually doing the calculation is extremely important. And so there's a lot of subtleties associated with what you might get out, and don't just decide that you can't accept surface brightness 80 a priori. Like make the calculation and see how much of a hit on the signal to noise is it. And okay, if it's a decent enough hit that you can't do your science, but you can increase the integration time at the expense of another target, what you do with your time is essentially up to you once you have the accepted program, as long as it's still within the scientific umbrella of what you propose for.
Fantastic.
Oh, one other thing I'll mention is that making sure that your observing modes are not too restrictive. So, like for example, the camera turret on GNIRS has had some issues over the last year, and so that means we're locked into a given camera position on a given night, and most of the time we're in short blue. We have 4 different cameras on GNIRS, 3 of which are usable right now: short blue, long red, and long blue. And so if you propose for a long red or a long blue program, and we do a couple of 1-week blocks throughout the semester with that camera. If your program doesn't get timed during those blocks, let's say it's weathered out or something, considering whether you can still do your science with a short blue camera, being flexible on that, or LGS plus P1, our super seeing mode. Maybe you can accept IQ20 instead. And so if our laser isn't working, taking the best possible image quality conditions at Maunakea or at Serpachon, that can be an option as well. So constantly thinking about what your program might be able to accept, and being abreast of the news that's happening at the observatory. So we try to put up anytime if GNIRS is having an issue, I'll put on our GNIRS website news about, hey, listen, our camera turret isn't working great, so we're going to be doing camera blocks, or there's degraded detector performance, or no, actually it's back, where we have wonderful detector performance again. These kind of things, just keeping an eye on that is really, really important.
Follow-up from Renee. In your experience, how accurate are the ITC calculations versus reality? Is it 10%, a reasonable assumption, better, worse?
I actually saw it with, I was supporting, so I was part of a fast turnaround proposal last couple cycles, and I was supporting a friend of mine who was the PI, or who is the PI. And we were finding some holes, honestly, in the ITC estimates. So where like water vapor wouldn't correlate well with the skylines in the red optical. We would see dramatic changes where we shouldn't see changes. Surface brightness differences didn't move in the right direction. So we were actually getting higher signal to noise in SBNE than we were getting in SB50, which is nonsensical. But this was really subtle. This was like at the, like, are we getting for a very faint target? And so like, are we getting 4.5 sigma detection versus 5 sigma detection? So that would be, roughly 10-20% level. It was okay. And we were looking at particular skylines. This was one emission line that we were trying to recover in a forest of OH lines at about 9,500 angstroms. In general, just broad brush, you can trust it pretty well. 10%, yeah, I would say that's probably a good guess. I mean, keep in mind also that the ITC is very conservative. So it takes, so if you put an IQ 70 CC50, it's going to take the worst possible IQ 70. IQ 70 is quite large. I mean, from IQ 20 to IQ 70, that's our range there. That's our bin. That goes all the way from like in the R band, that would be like 0.6 arc second seeing, 0.55 to 0.8. So you can imagine it's going to, if you're taking imaging or spectroscopy of a point source, you're going to get a lot more signal to noise at 0.55 arc second image quality than you are at 0.8 with a 0.5 arc second slit. And so you are generally going to do better than the ITC because you're, by definition, if we're at the border between IQ 70 and IQ 85, which is where the ITC would estimate the output signal to noise, we're probably in the IQ 85 variant. So we're probably observing IQ 85 programs. So anytime you get data in IQ 70, you're probably solidly in IQ 70 or it may even be an IQ 20.
Wonderful. That's all the questions we have for right now. And I will just highlight for everyone that Eric Steinbring has rejoined us. Welcome back, Eric.
Welcome back, Eric.
Hello.
So let me share this. Okay, so let's ground this in reality. So here we are on Maunakea. So we're actually in Hilo at our base facility. And this is our Gemini North status page. This is a super awesome page that you can go to at any time. It's public. And it has all sorts of information. So up at the top here, it's the target of opportunity availability. So whether or not people can trigger tonight, we just had a trigger. That was the observations that we were taking just as we started the session. What instruments are available in terms of the facility instruments, anything about the configuration, so the GMOS configuration, the GNIRS configuration, whether we're open or not, taking observations, and then our cloud cameras. So these are mounted on the observatory structure on the summit of Maunakea. And this is looking towards us in Hilo. South facing cam, west facing cam, IRTF is there. This is KEC2, and IRTF again in the north facing cam. This is Maui right there. It's Haleakala. And then the up facing camera. So this is these are super light sensitive cameras. This allows us to assess if there's any cirrus, so on and so forth. And then these are real-time conditions. So this is from the CFHT sky probe. This is the attenuation over the entire sky. So we're in CC50 conditions. This is water vapor estimates from JCMT and from SMA. We're currently in water vapor 80. We have image quality measurements. These are from the CFHT tower seeing, which there's no measurements today because things are down over there. But we have all of our estimates, so you can see the seeing has varied quite a bit this evening, all the way from IQ 20 at around midnight to now IQ NE, just as we're entering into twilight. And then we have some environmental parameters as well. So these are all wind measurements and relative humidity, temperature, particles, which is important because Kilauea has recently erupted, and so that can affect our observations as well. It's very foggy these days. So this is actually what one of our observing screens that we have for tonight. So Jen has 8 screens up, and then Layla also has 8 screens up. So a lot of information. I'm just on one of those screens. We're taking GMOS observations right now. Looks like imaging observations. And this is, we're now in weather loss. Actually, we went from band 1 rapid TOO to weather loss, just like that. So it's all over the place on a given night, and it's the observer's job to make sure that we stay within the condition constraints. So as I mentioned, we had a trigger, actually 2 triggers tonight. One around 1 in the morning. Is that right, Jen? I think it was around 1.
Yeah, the first one was at, let's see, where do I have it? 1:30.
1:30.
And the
So
second one, yeah, the second one was at 4:20.
4:20, like right before we started the session, yeah. So yeah, we had a trigger for a GRB optical follow-up. So GRB went off, the PI triggered, GMOS imaging was taken around 2 o'clock, so half hour after the trigger or something like that. Then the PI analyzed those data, found the optical counterpart of the GRB, triggered again for GMOS long slit observations, and eavesdropped, and that's I had to run over for QC duties to check, like, it's super faint optical afterglow. And so we were making sure that the target was that we could find the target, and the target was definitely in the slit. And then we got spectroscopy of that afterglow, so that optical counterpart. So the PI probably, last time we did this, I think this is the 4th time we've done it this semester. Last time we did it, the PI had a redshift for that source within 2 hours and emailed us and let us know what happened. And I think that particular, not the one taken tonight, but the previous one that I was a part of, the redshift was like 4.6. So it was it was out there. So on the right here, you see our instrument status display. This is all the optical elements of GMOS. We also have ALTAIR and GNIRS open. And so this is what the observer and the operator, which is Layla tonight, keep an eye on as we're we switch between instruments all the time. And we, each one of these instruments has 10 to 15 configurable elements. And well, IGNIRS doesn't. IGNIRS 2 doesn't, but GMOS and GNIRS do. And so we keep an eye, make sure that all the mechanisms go into place. And we can always check if like for example, the grading that we want is in the grading turret for GMOS, since every once in a while an observation can slip through that requests a grading that we don't have in our turret. This is actually a good, yeah, awesome. Thanks, Jen. So I actually just asked for a grading exchange today. We always have the R400 and B480 in. So this is GRB and GRC, not to be confused with the other GRB. And then GRD, so the D slot in our grading turret, this is gets changed in and out on a pretty regular basis. So right now we have the R150 grading in, and this is something I actually didn't cover when we were talking about flexibility, but it falls under the idea of like not requesting too specific of an instrument mode. So R400, B480 are always in, modulo any issues with them. R831, B1200, and R150 are all exchanged in the north. And so if you request R150, R831, or B1200 observations, know that you're automatically decreasing your chances of getting an observation by 67%. So throughout the semester, we take the collective demand, and it's weighted by band, of course, but we take the collective demand for each one of these gradings. And same thing goes for the IFU. We have IFU-R and IFU 2-slit. So these are mutually exclusive. And so if you ask for IFU 2-slit, roughly 50% of the time during the semester, it's going to be available. And so if you ask for R831, consider whether or not R400 would be good enough for you. So do you actually need the resolution that you think you do? Or can you manage with a little bit lower resolution? The program that I'm PIing on Gemini South this semester, that's R150. And it's band 2. And we've still gotten a lot of data, but it's because the conditions have been pretty excellent at Gemini South for quite some time. So had they not been as good as they've been, I may have shifted to the R400 at some point just to get some data. Let's see what else. Think so. We're already at 6 o'clock HST. So maybe we could go through some phase 2 examples. Zach, can I pass it to you to do the Alopeke easiest possible case?
Oh, well, that means I have to bring up EOT, so that could take some time.
I think I have the program somewhere up here. Hold on one sec. Stop sharing. Again, if anybody has any questions, more than happy to answer them.
Absolutely. These have been really insightful questions. So just keep them coming, post them in the chat, and we will definitely get to them. Thank you so much.
All right, you got something, or
I'm still looking for my OT. I have too many screens up.
nice. All right. Well, I think I've managed to get it. Let's see here. That's it.
And while you're getting set up, Zach, we have a question from Renee. Do you have an ADC in Gemini North? I know there's none on Gemini South.
ADC in MAROON-X, yes. It's internal to the instrument. we do not have it on. Do we have it on GMOS? I think we have it on GMOS.
What
The
about,
telescope also corrects for atmospheric dispersion, so we know the band that we're taking the observation in, we know the time that we're taking the observation in, so we actually make a correction for the pointing for atmospheric dispersion. I'm not sure how much the GMOS ADC works. I haven't looked into detail on that.
and
Alpaka,
okay, yes, go ahead, Zach, thank you.
they do not. I can answer that right now.
The South.
Alpaka and Zorro do not have ADCs.
Okay.
All right. All right. I think that's sharing. So yeah, so this is an example of an Alpaka program. This is my program for this coming semester. This is actually for Zorro. Actually, now that I'm looking at it. But it's the same thing for Alpaka and Zorro. So for basically when you have put in your programs, for the most part, I believe all of you will have at least most of you will have all of your targets in the phase 2 if you put them into your proposal. Otherwise, you have to add them manually. So if you were to open up your phase 2 and go in, you would see a templates thing, and it would be set up for whatever instrument you want to use. In this case, it's Zorro for me. So you'll have a screen that looks like this. You'll have your targets, you'll have your conditions, you'll have the amount of time on each one. And then you can just go down and click apply, and it will do it for all of them. I'm not going to do that because I already did it. And it will just make a whole bunch of them over all the observations on the left side. And then you'll be able to go in and modify them. So for Alpaka, it's actually really easy because for the most part, what is really necessary for them is the configuration tab. But just to give you an example, this is kind of what the Alpaka looks like. The visitor instrument. You can put for Alpaka and Zorro, it's an interesting time with it because. For speckle imaging, the way it works is you're going to be taking a certain number of data sets or data cubes. And these cubes are sets of 1,000 images that are taken at extremely fast speeds. So for Alpaka, they take them at 60 millisecond frames. So each data cube is effectively a minute. And the number of data cubes they take per target is variable depending on the sky conditions that you're in. So unless you specifically go in and you say, I want X data sets per target, which you can do. And actually, that's what I do for this program. But otherwise, you can just let the speckle team decide how many data cubes you want to, or data sets you want taken that they will take per target. But you can go in and you can say, I want X number of frames. And actually, I do this for this one. I basically say that I want like 18 frames per target. And I also modify a couple things in here, which I'll go into. Like I mentioned that the frame time was 60 normally. I'm doing it at 20 because these are very, very bright targets. I mean, 12 Ophiuchus is what, 5 in the V. And I'm pretty certain there are some 2 and 3 magnitude stars in here, so this will be the fun times this semester. Sorry in advance to.
It seems to be the new trend to observe magnitude 2 and 3 objects with 8-meter class telescopes these days.
Of course, why not? And so for Brian will show off GMOS and GNIRS for what this tab looks like for Zorro and Alpaka, and for a lot of the visitor instruments. This is actually this is what it is. And so for Alpaka and Zorro, it's very straightforward. Here you set the observing conditions. You can either set them here or you can set them in the template. Whatever it is, this is where you would do it. Your target is set up here. A big thing for the target, if it really is helpful to have the proper motions. And so a lot of times, if you don't provide the proper motions, your contact scientist may bug you and say, "Hey, what are the proper motions for these?" Especially if you're dealing with stars. If you're dealing with extragalactic, then probably not. But stars, they'll probably bug you. And at least having a magnitude is great. The other thing that is necessary is for you to have a guide star. And so one of the things that may happen is that the OT has a auto guide star lookup. So that's what this is. And you can see it found a guide star. And I'm actually will this share this screen? Of course not. It will not share this screen. Give me a second. I need to switch over to this screen. Where is it? Here it is. Go to that screen. So wait, before I do that. So if you have to set the guide star manually, which is where there's a exclamation point here, it will actually be red if you need to set the guide star manually. So you go up here and you click on this image tab at the top. And that will shoot you over to this page. Where is it? Here it is. Share. To a screen that looks like this. It will show where your star is, where your observations are, and it will highlight possible guide stars around the field. And so in this case, no, it's not going to let me drag the screen around. Lovely. Oh, there we go. So in this case, it found a guide star up here, but if there were no guide stars in your field, then you'd have to do some fun times of trying to figure out what guide star to use. So for example, you know, for Alpec and Zorro, the field of view is very, very small. It's only a couple of arc seconds. And so this silhouette here is of the guide probe. And so you can see where possible vignetting might occur. And for GMOS and GNIRS, it's a little bit better because they actually have the field of view windows drawn. So you'll be able to see that directly. But for Alpec and Zorro, pretty much as long as the yellow areas are not anywhere near your target star, like pretty much within, let's say, oh, come on. It won't draw a box anymore. Pretty much anywhere in the center region. So for example, I could go and probably utilize, oh, that's because this is saved already. So I could probably go and utilize the star in the lower right here, even though it's within the nominal boundaries of where guide stars are, or the guide stars can be located, just because the field of view for Alpec is so small. So that's pretty much it for Alpec, I think, and Zorro. And yeah, I mean, the big thing, I guess I'll mention this. The big thing with the Alpec and Zorro programs, if you ever do one, and especially if you're doing wide field mode, is this configuration note is needed because there's not a lot of information here within the visitor instrument tab. For our Alpec and Zorro programs, the contact scientists and the NASA Speckle team really rely on this configuration note being as concise and precise as possible about what you want from these observations. And so having that set up correctly is the key thing. You know, the big thing for us, for the Speckle team is, you know, we want to see what filters you want to use. We want to see what exposure time you want and the number of sets you want per target. Or if you just want to have the Speckle team choose the amount of sets per target. And that's given by a table on the Alpec and Zorro page. So that's Alpec and Zorro, and I have no idea how many people on the Zoom call will probably use it this semester, but if you ever want to use it, there's a helpful OT tips for that. And now I'm going to pass it over to Brian for GMOS and GNIRS.
Yeah, and I think it's either you or Andy that wrote the phase 2 refresher notes for
That is totally
that was totally Andy. Okay. Yeah, so this is this is what I shared earlier. So that this is the like kind of high level phase 2 refresher notes and common oversights. And this is a document again that was written by all the instrument scientists, instrument teams. It's pretty verbose, a lot of information, and it was originally intentioned as for staff and for NGOs to help support program teams. But there's a lot of useful information in here. So take a look at that once you're at the end of your phase 2 process, at least what, when you think you have your observations ready, and just double check that none of these mistakes were made. Of course, we'll, always check the same thing on our end. So, it's not, you're not the last vanguard of your observations. There's plenty of checks at the observatory level. Okay, so Zach showed the OT, and hopefully y'all are kind of familiar with the OT at this point. Let me share. I'm just going to share my whole entire desktop. So here is just a random workspace that I have. So this is every staff has this workspace that helps them check out templates and get programs ready and everything. And so these 2 observations highlighted in pink are GMOS observations. These are long slit in this particular case. As Zach showed, there's all these different elements underneath a given observation. So these 2 together make a pair. This is an acquisition sequence, and this is the so-called science sequence. So this is the dispersed data here. This is the non-dispersed data here when we're acquiring on the source. And so whereas Alopeke and Zoro have not too many configurable elements under the instrument component, GMOS and GNIRS have quite a few, and this is where you set up all of your configurable elements. When you apply your templates, in general, this will all be set up for you. So if you want to make modifications to what you had from phase 1, so supposing, you wanted to change your disperser, so you wanted a different grading than what you had before. So you wanted to go from R150 to R400, you would do this under the GMOS North component here. And so this would be which disperser you're using. In the case of an acquisition, you always want to use the mirror. But for your actual science sequence here, you can change this to a different dispersing element. So central wavelength, which order you want to use. This should never be touched. We're always using Amamatsu. This is a big one here. So your position angle. So if you're using the long slit to get 2 targets, then you would want a fixed PA. If you are just observing a single target, usually you'd want to set this to the average parallactic angle. And this is something that the observers set up. So in this particular observation, it's set up as average parallactic for 2022, April 29th. So we can actually change this. So I'll set this to now plus setup, and it's going to flip. Oh, not too much. And so then an on-instrument wavefront sensor star is automatically picked up for the conditions that we have set, which are SB80 and then everything else any, and elevation constraints. And so this guide star will work for this particular observation. And when I go to the target component, not only can we see the target that I'm interested in, which is an elliptical galaxy at redshift 0.2 that has this spatial profile and these brightnesses, but we can also see the guiding speed that's predicted for these conditions. And so some of the time, especially for like TOO triggers, usually the condition constraints are any. And so you can actually change these just to check if under better conditions, you'll be able to guide. And so you can see when you go from, in my case, IQ any, cloud cover any, to IQ 70 and CC 70. A bunch more stars, as highlighted by the green circles, much more stars become viable guide stars for this observation. So whereas if I switch it back to the conditions before, you can see all of these are highlighted in red, meaning we can't guide even under the slowest speed, which is 50 Hertz. If the conditions are better, so less clouds, better seeing, all of these become viable guide stars. And so we can sample a much larger range of parallactic angles than we could before. So this is something to check during the phase 2 process. Do you have a star? Is there a star for whatever guide are you using, whether that's OI wavefront sensor or peripheral wavefront sensor 2, or in some cases peripheral wavefront sensor 1, that is capable of guiding reasonably well. And so now that I've increased the quality of the conditions, the guide speed has moved from slow before to fast. And this is actually incredibly helpful because it's slow is 50 Hertz. That doesn't take out some of the vibrations from the GNIRS cold heads. And so the image quality can actually be reduced under slow guiding conditions. But if we guide at 200 Hertz, which is the speed for our on-instrument and peripheral wavefront sensors, that vibration is mitigated to a large degree. And so you get better image quality. And so playing around with this is incredibly important during phase 2. You can also change which wavefront sensor you use. So instead of using OI, we can use P2. And then P2 star would be selected here. Zach mentioned when he was showing off the Alapeke Zoro observations, this is the P2 probe arm. This mostly opaque yellow region is the area where the field is completely vignetted. The more transparent yellow region is where it's partially vignetted. The actual observations take place here, so you can see that well away from even the partially vignetted region. So no loss of light due to this particular choice of P2 guide star. One thing that's important is that P2 has flexure with respect to every instrument. MAROON-X deals with this with its own internal tip tilt, but GMOS and GNIRS, for example, don't have that capability. Same thing for F2. Actually, does Ghost has an ADC, right, Zach? I think Ghost has an ADC, but it doesn't have an internal tip tilt. So yeah, if you use P2 guiding, then you're always going to have to reacquire. The observers will have to reacquire every 1 hour or so. So keeping that in mind for the overheads is important. GMOS has an OI. There's no flexure with respect to the instrument itself because it's on instrument. And so you don't have to worry about that reacquiring. So yeah, that's the basics for GMOS. Observing conditions are always set here. This is always populated based off of what you have in the phase 1. You can always downgrade conditions if you need. So flexing, if your program can handle it, and flexing would just come in a note. So it would be something like this. So at EQ coordinator can flex to different conditions. So in this particular case, I have set up IQ 70, CC 50, SB 50, water vapor any. And then I write to the QC at Gemini South and I say, but you can flex this to IQ 70, CC 70, or IQ 85, CC 50, or IQ 70, CC 50, SB 80. So I'm giving them a lot of work. I'm sure I'm very annoying for the QCs in the South. But it allows for a lot more variation in terms of scheduling. If you want to increase the quality of the conditions, so supposing you want to go from IQ 70 to IQ 20, that requires writing to your contact scientist, who will then contact the acting head of science operations or head of science operations here at Gemini North or Gemini South, and that has to be approved. And then there's the sequence iterator here. And this gets a little bit complicated, especially with the iteration configurations. So in general, try to stay away from these iteration configurations. This is sometimes not possible, but there's crosstalk between what is input here and what's input at the higher level. And so you have these, like you set up the disperser, you set up the central wavelength, the exposure time. And then in this particular case, when I take a science observation, I also have those set, exposure time 1200 seconds, disperser R400. This is completely redundant, so you don't need to do this. This is actually like a poorly set up observation because I could remove all these configurable elements. And so anytime you add something that you don't really want there, you just first delete item and that'll remove it from the iteration configuration. If you accidentally click on something like FPU, sometimes it'll populate it with something that's not sourced properly from here. So in this case, alongside 1 arcsecond, that's correct. But every once in a while, especially if it's not precisely set up in the high level instrument component. So one example would be the camera for GNIRS. That's set by a combination of the pixel scale and the central wavelength of the observation. But you can actually set the camera as a separate element in the iteration configuration. And so when you click on iteration configuration, it'll take its best guess at the camera, but sometimes it misses in terms of the guess, or you want something other than what is standard given the wavelength and the pixel scale, given the wavelength. And so it misses the guess, and then we go into a camera mode that's not actually capable of being observed that given night, and then we have to throw the program back to the contact scientist, and we have to make edits, and so that means you missed a chance at an observation. So yeah, try not to mess with that too much, but you do have to like change like central wavelength, for example. So if you're dithering on central wavelength, the first two observations here, so we have the first two science observations, 1200 seconds apiece, which is the max for GMOS, then arcs and flats on sky, then arcs and flats at a different central wavelength, and then the associated science. And so those need to be changed here. So like the grading central wavelength needs to be changed here.
Brian, can I jump in with a few questions?
Yeah, of course. Yeah, I was just gonna ask.
Perfect timing. Okay. I'll post this in the chat for everyone. Okay. First from Jonathan, how do we need to handle guiding for phase 2 if we don't know our TOO targets yet?
Yeah, so TO, don't worry about it. This is something we pick up once you trigger. And you know, average parallactic angle, for example, this is getting the guide star is completely at the discretion of the observer. So, I mean, it may be, you don't know the average parallactic angle a priori because you don't know when your observation is actually going to be taken. And so you just set it to average parallactic. The observer, when they're about to slew there, they'll do exactly what I just did, which is update the average parallactic angle. And then look for a good guide star. And so if they can't find one, usually we'll flip it by 180 if that's possible for like a long set observation. That's possible. In fact, Jen and I just did that earlier this evening. And then try to pick out an appropriate guide star. If not, we'll move a little bit off of parallactic and make a note of that in the program just to pick up an appropriate guide star. For TOOs, you have no idea, right? You don't know the RA, you don't know anything except for the instrument configuration, and you may not even know that. And so don't worry about it. We'll take care of it as soon as the trigger happens. It'll either be the contact scientist, the Q coordinator, or the observer, depending on when exactly during the day or night you trigger.
Our next question is from Renee. So in GMOS, is it absolutely necessary to take arcs with every science observation? Or is the wave calibration stable enough to take them at the beginning or the end of the night? And how much time does an arc actually take?
So arcs are pretty quick. This particular one, I think, is 11 seconds. Is that right? Yeah, 11 seconds. There's a few setups where it's a little bit longer. but not too much longer. So it used to be actually our policy before this semester to take ARCs during the day for GMOS. And so we wouldn't take on-sky ARCs. We would take on-sky flats because of lecture, but we wouldn't take on-sky ARCs. However, it was found that the grading turret has a little bit of non-repeatability in its movements. And there's hysteresis as well. So if you go to like R400 and then you go to another observation, V480, another observation, R150, and then you say, okay, I'm done for the night. Let's relax and let's take our daytime calibrations. You go back to your original R400 at the same central wavelength. The central wavelength might actually be off by a little bit just due to this non-repeatability of the movement of the mechanisms. And so we didn't want to have people have to deal with this. You can deal with it. It's relatively easy to deal with. You just put in for observations that have skylines, you just do a quick tweak on the wavelength solution on the skylines, and there you have it. You have your wavelength solution. So you have a baseline wavelength solution from the daytime arcs, and then you tweak that based off of the skylines. Of course, in the blue, that's harder to do, or if not impossible, since there's a dearth of skylines there. But for most observations, you would have the capability of making that tweak. However, as an observatory, we decided to move the policy so that every single observation, long slot observation, MOS observation, IFU observation has an associated on-sky arc that is partner time. So it's not charged to the PI, it's charged to the general pool for that particular partner. So you're not obligated to have it, but it doesn't cost you anything as a PI. Generally, I would suggest to use it. Then you don't have to worry about tweaking the wavelength solution.
Great. So if you have any other questions, we're about 7 minutes until the end of this session, I believe. Zach and Brian, am I right?
Yeah, I think so. And probably the observers are just coming close to wrapping up for the night. I can't remember when is 12 degree?
It was at
6 in the morning, right?
so 8, I think, and we're just slewing to some twilight flats.
Oh, awesome. Okay.
Yeah.
Great.
Yeah. So
Cool.
I think I'll skip the GNIRS one just because GNIRS is well has a lot of moving parts, and I'll just say that if anybody has any GNIRS related questions, as I mentioned, I'm one of the instrument scientists, one of 2 instrument scientists here at the North. So feel free to email me. I think my email's no, it's not in the presentation, so I'll put it in the chat.
So we have a few more questions. First one I'm posting now, and it is to all the speakers. Do you have professional social media that we can follow? So please share those.
I don't. Nope. I got enough going on in my life that I don't need professional media. I'm not on social media or anything like that. Already too much noise in my life. Yeah, we're on Shadow the Scientist sessions very regularly. So I mean, you definitely can interact with us. I do one public session at least per month, and if not, multiple. I of course post on the GNIRS website pretty often. So that's one way that I get information out to people. No, nothing public.
And
Zach, I know you're a social media star.
Totally. I have not.
Yeah.
All right. So the best way to contact you is via email.
And Eric put his LinkedIn
Wonderful.
link there.
Thanks, Eric. Okay, a few more questions. How was the scheduling set up in the OT considered in the queue planning?
Raylan, do you mind? I'm not totally sure what you mean in your question. Do you mind like unmuting and asking? Or maybe just like putting in the chat. I guess so is it like you're talking about if you have multiple observations set up together, like how are those scheduled?
Feel free to unmute, Raylan. Okay, so
I can take my best guess, no problem.
oh, got a clarification here right now that I am going to be sharing for Raylan. And it's in the schedule option for each target, how strict can the schedule be?
So like you can do timing windows, for example. So timing windows, you can set them up to the minute. I mean, we adhere to the timing windows that any PI or a program team puts in. And so if you say it can only be observed, I don't know, from in this 30-minute block, then we will only observe it in that 30-minute block. We will not make any exceptions unless you tell us otherwise. Same thing for elevation constraints. If you put air mass 1 to 1.5, we do not go past air mass 1.5. So we adhere to whatever you have put into the program, and that's a double-edged sword because what if your observation could be scheduled if you put 1.52 here instead of 1.5, right? As a QC, I can't schedule past 1.5, but if you say, well, I can take 1.5 plus epsilon, it's probably not going to affect your data quality too much. And so making sure that you're flexible again about that without compromising the science is really important. But yeah, I mean, so for like MAROON-X transits, for example, these are 4 to 9 hour observations, and those are scheduled within, I mean, they have like 5-minute buffers, and we're on it. Like we go to it and we take the data like right when the timing window opens, and then we close it out right when the timing window closes. So I mean, it's you can be as strict as you want. It's just, can we schedule it, and does the universe provide for you during that time? Because if you have one shot at something in the entire semester and it happens to be cloudy on Mauna Kea and you can't accept clouds, well, oops.
Okay, next from Barbara. Congratulations on this amazing session. What is the biggest challenge in being a scientist at Gemini, and what is the best part?
So Zach, do you want to give your experience? So you no longer have to toe the company line since you're not at Noir Lab Gemini anymore. So you also had a different role too, right? You were a science fellow versus a staff scientist.
Yeah, I mean, probably the biggest challenge is either, and this is speaking more to, just trying to, as an early career researcher, trying to eventually make it in the astronomy world. It's, for science fellows, it's really about finding balance, getting a balance between helping out at the observatory, but also getting the research done that you need to do because, like it or not, papers rule the world, and that's how you get the other jobs. And so probably the biggest challenge for science, being a science fellow at Gemini, was definitely, I want to help out. I want to do all these great things. I got involved with the grad visitor program and wanted to keep doing that, but it's like that's not going to get you the next job. You have to get the papers out and stuff like that. So definitely managing that balance was my biggest challenge at Gemini. The best part is just working with everybody and being part of the team. It's, working at, like, everybody at the observatory is working towards the common goal of getting the best data possible for all of you. And being a part of that team was really great. And yeah, that was the best part for me. I don't know. So
You're still with us, Zach. Come on. Not in the past. You're doing a new Gemini user session right now, so you're definitely still part of the team. Yeah, I would echo what Zach said. I mean, balance is incredibly difficult in observatory, and it's like it cuts both ways because like there's so many things you could be involved in. And I lead my own research team, and I have plenty of mentees, and I do outreach, and I'm an instrument scientist. I'm doing phase 2, and I'm doing QCing, and I'm doing observing, and here I am at 4:30 in the morning, waking up for a session, and then I'll go and do QCing duties all day. So that is not easy, and I also have a 2-year-old, so no one has to balance all these things. um, but the dynamic of the observatory is so amazing, and coming from an academia background where there are academic fiefdoms, and people are not necessarily working together for a common goal. I mean, they're the particular subsection of astrophysics that I'm interested in is protoclusters, high redshift protoclusters. That's a relatively small community. Usually we work together pretty well. But there's healthy competition, and we're not always working together on a common goal. That is not at all the case at the observatory. As Zach said, everybody is working towards a common goal of getting the best science, and it's people that are doing day crew work. It's people that are managing the facilities here. It's people that are observing at nighttime. It's people that are cleaning up during the daytime and making checks during the daytime. It's software, people that are getting the software ready, that are diagnosing the software when we have so many subsystems, the hardware, the software, and just knowing where your boundaries are in the observatory, like where you can stop and hand that off to somebody else. That was what I really struggled with, and I think Zach did as well. Like, there is so many things that you could be involved in, but there's also like a ton of awesome expertise here. And also at the greater observatory structure, like the NGOs, like Eric, for example, like, we're resources for them, and they're resources for us. And we're all a community together working to make the best out of these observations. And so knowing when to hand that off, take a break, go to sleep, and knowing that there's expertise out there that usually far exceeds your own, that you can trust is really, really important.
And maybe we can wrap up with one last question. I'll share it here in the chat from Renee. Has Gemini South and Gemini North ever observed the same target simultaneously, even if it's with different instruments?
yes.
Yeah, okay. Not since I've been here, I don't think.
It was right when you got there. Yeah, so when I first got there, we had a program my first semester that was looking at I think it was Triton. It was one of the moons in the outer solar system, and we got it both with Alpec and Zorro and Wide Field, and that was a fun time. But yeah, I still think that's the only one. I don't remember hearing about any other instrument that has been observed simultaneously. I mean, there have definitely been cases where, Ghost or like Maroon-X has looked at something and Ghost looks at it or something like that at a later date, but not simultaneously. I still think that that this observation was the only one.
Yeah, I think there's also been like triggers where like the program was originally on the north or the south, and then the trigger, and then there was like maybe imaging, and it's like, no, it's probably better to take the spectroscopic observation from the other telescope, and so we do crosstalk like that. But yeah, I don't remember that at all, Zach. That's super cool. I can't remember any observation that we took with both telescopes simultaneously. Jen's been here forever, so Jen, do you know?
Yeah, I mean, that's very rare, but not Gemini North and South, but we have had coordinated observations with other observatories on Maunakea.
Oh, that's a great point. Yeah. Also in space, right? Like we did simultaneous
Yeah.
observations with JWST
Yeah.
last last semester or the semester before, where yeah, the timing window was super tight, and they do that. The observations were being taken, and actually multiple times this semester we've been doing coordinated observations with TESS, with Swift. So yeah, there's always something going on. Thanks for your really nice note, Renee.
And I'd like to thank everyone for joining this very first session for the Gemini user community. And I will leave it with Brian and Zach and Eric to wrap us up.
Jamika, can I just add something really quick?
Please do, Jen.
That RTOO that we observed tonight, they're sending out a notice to the community of their discovery, and they're adding us to their notice. So that's pretty cool.
So they got something that they were able to confirm the redshift or something.
Yeah, I copied you on the email.
Oh, awesome.
Oh, that's great.
Yeah, so I think this is like something we didn't mention, which is like a really neat aspect of the observatory life is like, yeah, we get all these wonderful scientific ideas that, you know, I work on protoclusters, Zach works on binary stars, like things we would never think of. And then we get this like feedback immediately. It's pretty rare in astrophysics that you get that like that kind of feedback immediately. But just that we were able to affect exactly what the PI wanted, and then we were able to discover something new. So that's the job, that's the game. I'm sure that's why y'all are in astrophysics as well. So I think we can leave it there, but thank you everybody for joining. This isn't the end, this is the beginning. So excited for 25A. It's coming up in not too long, and you know, I look forward to interacting with all of you in some capacity. Feel free to email me, Zach, Shadow the Scientist, Eric. We're here, we're around, taking data, getting photons.
Aloha.
Aloha, everybody.